Hello and welcome to Web Math Academy. Today we're going to discuss some properties of definite integrals. And by definite we mean an integral between two numbers, such as the integral of 3 over 1 f of x dx, rather than a general or indefinite integral, which will be discussed in the upcoming tutorial. First we take some examples to become more comfortable with using integrals. Here's our example from the last tutorial by way of review. What is the integral from 5 to 2 of x squared dx? Well, here the antiderivative or integral of x squared is x cubed over 3 equals f of x. Now this is because the derivative of x cubed over 3 is x squared. So we plug in our numbers of 5 and 2 into the x cubed over 3 equation and we get 5 cubed over 3 minus 2 cubed over 3 equals 39. And that is the integral of 5 over 2 of x squared dx. Okay, simple enough. Let's try the same thing using a square root. What is the integral from 5 to 2 of the square root of x dx? Well, the square root of x can be written such that x to the 1/2 power, so that the integral then becomes 2/3 x to the 3/2 power. And we note that this is the case because if we try to take its derivative, we get the original x to the 1/2 power, and that's shown here. So we solve 2/3 x to the 3/2 using 5 and 2 as our values, and this is best left to our TI-Nspire CAS calculator, which gives an answer shown on the left. 10 times the square root of 5 over 3 minus 4 times the square root of 2 over 3. That's the exact answer. It can be approximated by solving with your calculator. Okay. Let's try an integral with a power in the denominator. What is the integral from 5 to 2 of 1 over x cubed dx? Well, here 1 over x cubed can be written x to the negative 3 power, so that the integral then becomes negative 1/2 times x to the negative 2. Again, work backwards to find the derivative to confirm your calculation. The solution is given on the left. The integral from 5 to 2 of 1 over x cubed is 21/200. Now, integrals have the same property as derivatives when adding or subtracting, and that each term can be integrated separately. Let's try this integral. The integral from 5 to 2 again of minus 4x squared minus 1 over the square root of 2 dx. Now we use the same procedures that we outlined above to solve this. First we separate the integrals so that we have the integral from 5 to 2 of negative 4x squared minus the integral from 5 to 2 of 1 over the square root of 2. Now using these same principles we come up with the integral in red. Negative 4/3 x cubed minus 1 over the square root of 2x. So I want to show that just by way of an example that the 1 over square root of 2 is a constant and the integral of a constant is simply cx. So in this case 1 over the square root of 2x. So we solve this with x equals 5 minus x equals 2 and that gives us the solution on the left. Negative 3 times the square root of 2 over 2 minus 156. Again, that can be calculated out to give an exact value. I believe it is negative 158.121 would be the approximate value. Okay, one more. Let's take the integral of 5 to 2, 16x to the negative 4. Here, a constant can be brought outside the integral and simply multiplied by the result. And this allows us to have an easier integral. For example, here, the integral of x to the negative 4 is negative 1/3 x to the negative 3. If we had the 16 as part of it, the integral would be negative 16 to the third times x to the negative 3. So, applying the solution gives the result on the left, 78 over 125. Next time we'll discuss indefinite integrals and also how to find errors between two different curves. Thank you.